In test item 3, we're asked to find what is in essence two equivalent but opposite force couple systems. We've got the 21 pounds force couple system that wants to tend to rotate this body in a counterclockwise fashion, and we have a 12-pound force couple system that wants to tend to rotate it in the opposite direction. We're supposed to find D, that separation distance between the two 12-pound parallel forces, in order to equilibrate the rotational effect of the 21-pound. And there's a variety of different ways to represent the math here. One simple way to do it is to just look at summing moments about point A. This is perhaps a longer way to articulate the answer, but if I sum moments about point A, let's take counterclockwise as positive. Note that the 12-pound force that looks like it's applied at D will pass right through A, so therefore has no moment arm. The 21-pound force applied at point A also has no moment arm, and so I'm left with, then, there's a 21-pound force times a perpendicular distance of 16 inches to A, right? And that's going with respect to point A in a counterclockwise pattern, so that's positive. And then I have the 12-pound force that if I were to break up the 12-pound force into its scalar components, notice that the x component will pass right through point A, leaving me only then the y component force. And so I need to consider what this angle is. Alpha was equal to 70 degrees, so the narrow one has to be 20 degrees, and so the force will be 12 pounds times cosine of 20 degrees, and then the perpendicular distance is D, what we were trying to find, and note that it's going in a clockwise fashion about point A, so there's a minus. Set that all equal to 0, that's a statement of equivalency, or in essence equivalency means, in this case, equal and opposite, that we have equilibrium. So set that equal to 0 and solve this for D, and you get to 3 significant digits, 29.8 inches. Right? Now note that another way you could have thought about this, and it would have been exactly equivalent kind of approach, was to go directly at this in terms of the effect of the two force couples being equal and opposite. You could have said, hey, 21 pounds times 16, that's the perpendicular distance between in that force couple, and that's equal to 336 pound-inches in a counterclockwise fashion. I have to also have that force times perpendicular distance between the other force couple at work, and so I can find that perpendicular distance between them two by saying, okay, 12 times this d prime has to be equal to 336 pound-inches. The 12 has units of pounds as well, and so therefore d prime would be equal to 28 inches. And so then you can see from the right triangle that is formed that d prime is equal to, there's a hypotenuse and an opposite there, so that we want the sine of that angle. So d prime is equal to d times sine of 70 degrees, and now we can solve for d, and we'll get the same thing as before, that d is equal to 29.8 inches, actually 29.79 when you round to 3 significant digits, you get to the 29.8 as before.